Hello, everyone, and thank you for joining us today for our AGU-AGI Heads and Chairs discussion series. My name is Leila Gonzalez, and I'm going to be sitting in for Chris Keene today. And joining us also is Pranoti Asher, who will also be co-moderating this event. And she's the manager for higher education at AGU and AGI Scholar in Residence. And with that, I'll go ahead and turn this over to Pranoti.
All right. Thank you, Leila. Thank you very much. Good afternoon, everyone, or good morning, depending on where you are. We're very excited that you have joined today's webinar and discussion about a topic that is of great interest to the geoscience community. Our speaker today is Dr. Sharon Mosier. She's the Dean of the Jackson School of Geosciences and a professor at the University of Texas in Austin. And she's going to tell us about some of the work that has been going on for the last several years related to undergraduate and graduate education and what the future looks like and what kinds of products are coming out of this work in the coming months and years. So without further ado, please take it away, Sharon.
Okay, great. Well, welcome. Please have you all join us. Jeff Ryan is in China, so I will be doing this on my own. The time change is a little bit much. As I think most of you know, most PhD and master's STEM students do not end up in academia. And so the question that's been asked is, in addition to their specialty, what do they need to learn in graduate school? This is a question that has been addressed in a number of ways for STEM students in general. For example, the National Academy of Science, Engineering, and Medicine recently put out a graduate STEM education for the 21st century in 2018, where they investigated what skills were needed by STEM students overall. And the Council of Graduate Schools in 2017 did a very similar study, Professional Development Shaping Effective Programs for STEM Graduate Students, both of which had very, very similar outcomes. The initiative on future of undergraduate geoscience education that we've been working on for the last couple of years, we're in the process now of writing up a vision and change document for it. And it had a lot to say about what not just undergraduates needed in order to go to graduate school, but what would therefore then need to be improved or increased when students became graduate students. And really the issue is that there's a real mismatch between graduate education and what most students do as future careers. Graduate students are really too narrowly focused on academic research. There's a tremendous number of professional and personal skills that are valued both by academic and non-academic employers. And they include things like teamwork, project management, leadership, and communication. And that students really need to have information about careers, what kinds of things they need to be able to do, skills and competencies for careers, and they need mentoring. And we need to be preparing our students not just for academia, but for outside of academia as well. Really, it's transferable skills. The world is changing, occupations are changing. Within academia, we're transitioning from interdisciplinary to multidisciplinary to transdisciplinary research. And that, of course, then has had a major impact on application. We do more things that are societally relevant in our research and obviously then in the application. The way we do research, the way we conduct science, and the technology we use has changed. And of course the demographics are changing. We're becoming more diverse and more global. And so graduate students, professional societies, employers, the Council of Graduate Schools, and National Academies of Science have all asked for us to move forward on looking at what students actually need. So what is the current landscape? Well, as the National Academy said, there's a lot of things that grad STEM education do for the country and for global society. And if you look at STEM PhD students, about half of them go into academia and half go into business. If you look at the geosciences, you have about 51% of the PhDs go into academics and about 4% of the master's students do. If you look at bachelor's students that are finishing, and this of course is all AGI work, about 8 to 9% of the PhD, 8 to 9% of the bachelor students want to go on for a PhD and an academic career, and about 20 to 27% want to get a master's degree, and of those, only about 16% continue for a PhD. The graphs in the bottom right, you don't need to be able to read it. Red is academics. This is from the Consortium Ocean Leadership. And you can see that for PhDs, it ends up being essentially half that go into academics. And for masters, it's a much, much smaller amount. Looking at AGI's most recent workforce report with 146 departments responding, most of which being PhDs, you can see that, in the last, 4 years that they have data, about half of the PhDs go into academics. It can be higher or lower, and at master's level, of course, it's much smaller. So all of this led the National Science Foundation to fund Jeff and I to look at improving geoscience graduate preparedness for the future workforce. And the goals were to identify skills and competencies. This is a little different than the undergraduate effort, where we also looked at concepts. And for PhDs dominantly, but also master's students, and in this case, earth, ocean, and atmospheric sciences. The undergraduate education looked at all of those, but it was really more focused on geology and geophysics. And then how do you develop these in geoscience graduate programs nationally, as well as working with heads and chairs and graduate program directors to find ways to implement these. We've done 2 events. One was a Geoscience Employees Workshop last October. We had about 52 participants, and they really did cover the broad spectrum of geoscience employers in earth, atmosphere, and oceans. We had industries, not-for-profits, other organizations, and it went from weather, climate, energy, natural resources, oceans, fisheries, environment, reinsurance, hazards, huge gamut. And then a lot of input from NASA in particular, as well as NOAA. And then we also, since they're definitely employers of PhDs, had some of the major research labs and universities represented as well, although the bulk of the people there were either government or industry. And they gave us a lot of feedback on what they thought academics should be providing in terms of skills and competencies for students. And also discussed how they thought things could go forward. They build on the Future of Undergraduate Geoscience Education Initiative and the reports coming out from national sources. We then had a Heads and Chairs Summit in May, 74 participants, mainly department heads and chairs, 59 from PhD granting universities and 5 from less, and it covered earth, oceans, and atmospheric science programs, and we had essentially 8 people that served on panels. And they looked at the input from the geoscience employers and the other studies on skills and competency needed. And in general, they agreed with the employers in terms of what graduate, PhD, and master's students actually have when they come out and what they lack. Most of the discussion focused on methods for developing the skills that the employers talked about being needed, and they ended up each writing an action plan for their own department for implementing this. So basically, looking at what the employers said, that in general the academics agreed with in terms of what do MS and PhD graduates need to be successful today and in the future, and also what do they lack. They need expertise, obviously, in their core area. Core technical skills, deep understanding of the fundamentals and the mechanics and techniques, and a good set of foundational skills. And it's wonderful to know that they say, graduates are generally coming in with very strong technical skills, that they have a really good knowledge in their field of geosciences, they have good research skills, they have good field skills. And I have to say it was really nice to hear that they felt that the students are coming in that way. It seemed to be across the board that they agreed. And they wanted to emphasize that they don't want us to get rid of this, even though they think there's other things that we should have as well. The most important skill, of course, is problem solving, critical thinking, obviously pragmatic critical thinking, logical thinking, flexibility, open-mindedness. But the employers indicated that it was really important for students to be able to define the problem, establish what is a sufficient solution versus a precise solution, and translating the problem to, so what? What decisions will be made based on the work you're doing? What is the importance of your outcomes? And understanding the broader impact. And so they really were interested in independence and critical thinking and problem solving development and execution and analysis of skills. And one of the things that they said, which really was striking, was that most PhD and master's students could solve a problem if you gave it to them, but they found it very difficult to define the problem. And they also found it difficult to identify how to apply the solution. And that is something that I believe we really need to work on. Teamwork generally lack. That's both the ability to work with other scientists and individuals, but to deal with conflict, value diversity of thought, develop self-awareness, recognize your skills in others, your strengths in others, and be coachable, take directions in leading. And of course, leadership as well, which they felt that in general students were not coming out with. And this just a little diagram indicates some of the different aspects that they thought leadership was important. Another important skill identified by the employers was communication, written, verbal, and both for internal audiences and external audiences. And this was something that they very definitely felt was a common limiting factor for most graduate students when they got out. It was really important that they learn to express technical work effectively and to a whole variety of different audiences. And that's both writing and orally, both within their own specialty as well as other science and engineering fields, as well as to non-technical audiences and management, the public, press, and convey the material in a simple way, expressing their ideas logically. They also said it was very important for people to be comfortable speaking to people when English was not their first language, and to be able to communicate the societal and or financial impacts. The employers also mentioned skills in editing and the ability to accept criticism and evaluate things critically themselves, and in particular, listening skills. It's important for students to learn to have a way of reading the room, to be highly sensitive to what audience they have, and to pay attention to what other people say. Conversations or discussions shouldn't be somebody waiting for it to be their turn to speak. It should actually be them listening and responding to what the other person said. And also being careful and learning to actually answer the question asked. A lot of times people just talk when they get asked a question and don't actually answer the question itself. Now, this is probably a good time for me to mention there's a lot of information on these slides, and I'm not going to go through all of the material on the slides. They're for people's use later. They are posted online, and I, at the very end, will give you the link for where you can find these. In terms of research skills, the employers had one in particular that they felt was critically important and was going to continue to be important. And this was something that cut across the entire employer spectrum. And that is data management and data analytics. Graduates need to be aware of data analytics, how it's applied, and the process for using data. That's, dealing with big data and big data sets, being able to examine data sets to draw conclusions about the information they contain. And in this is a whole lot of detail. It's very specific detail about what is necessary. That includes data acquisition and a wide variety of things under that, data management and analysis, data manipulation, data integration, which is really merging information and data to solve a problem, but it's different types of data that needs to be integrated and synthesized. And an example shown up in the upper right is a 3D seismic line where you're seeing some sort of fluids migrating through a specific layer. Also, data assimilation, data quality, visualization and modeling, valuation, how valuable is the data? In other words, what is it worth? And other data science, including machine learning, AI, robotics, and other things that they said would increase in the future. And this is one place that we notice a really large difference between what the employers said in 2015 in terms of undergraduates and what they said in 2018 for graduate students. And that is that all of the data management, data analytics, and even machine learning and such suddenly had become much more important. It was very obvious that what they were expecting undergraduates to know and then what they were expecting graduate students to have built on had really increased in the 3-year period. That's the same with computational skills. They felt it was very important for graduate students, masters and PhDs, to have good computational skills. That includes basic programming skills, coding, ability to analyze algorithms, keeping up with supercomputing, transition to cloud computing, modeling, and things of that nature. They also stress that more for undergraduates than they had, that basically saying undergraduates needed to come in with experience doing these things. And basics of statistics and math. I mean, this was something they were very clear in 2018 that undergraduate students should have when they're coming in if they're going to do PhDs or masters in the geosciences. And that's statistics and higher level math, including calculus, differential equations, and linear algebra. That these were things that were sort of basic skills that undergraduate students should achieve before they came to graduate school, and certainly make it up if they had not before. And they really were interested in students embracing technology and actually creating technology as opposed to just using it, and being willing to step outside of the box to engage in genuine innovation. They talked about habits of mind. And one of the things that they had talked about at the undergraduate education workshop was Earth systems thinking about the Earth as a system. It's interactive, it's complex, nonlinear, it's coupled, different processes interact. And they talked about that again at this graduate employers workshop, but they also talked about systems thinking in general. How to look at the entire system, the big system, that parts of the system in isolation might act differently, and in fact do act differently, than when they are combined within a system. So the need to be able to go from big to small and back to big to try to solve problems was felt to be critically important by the employers. They also talked about a lot of other concepts and abilities that we in general expect our students to have: the scientific process, importance of simulation, good grasp of uncertainty, how time and space are scaled, risk, impact of risk, and application-driven questions. There were 4 things that the employers felt were really critical for the students to have. One was the internal drive to do well, that students needed to overcome their aversion to adopting new technology to address major problems, and they need to overcome their fear of failure. Another was willingness to be a lifelong learner, that basically students really needed to learn how to learn because things were changing so quickly that the skills and knowledge they were gaining now would need to be refreshed constantly throughout their career. Also, the societal connection. They really need to understand that research has or needs a purpose. And being diverse and adaptable. It was less important for them to know or be able to do specific things than they could evolve with time. Additional things that they thought were important that students generally lack when they get out was project management and program management. Everything from understanding budgets and projecting financials to managing people and large projects, and understanding what factors drive the decision-making process and managing time and resources, and even just knowing how to run a meeting. Also, time value concepts. That's everything from time is money to the idea that money is worth a certain amount now and the same amount of money later will be worth less. They also thought that there needed to be improvement in terms of students' understanding and business skills. The importance of economics in making decisions and the impact of uncertainty and dealing with risk, innovation and entrepreneurship, and all these other kinds of things that they would need in a business environment. And so basically just exposure to the basics of business and how operations actually work. Other things that they thought were quite important, which most of us, I think, try to work into our graduate programs, is ethics and professionalism. Integrity, understanding what plagiarism is, attribution to appropriate sources, and things of that nature. And another thing that was not only generally lacking, but they felt was very limiting for graduate students when they came out was social dynamics, basic people skills, interpersonal behavior, how to deal with people who are different and from different cultures, and be able to work with them to on projects and to develop new ideas. Corporate skills, they talked a fair amount about culture class, academia versus industry, academia versus government, academia versus business, and how there was a difference in what you really needed to be able to do. And a good example was being able to distill everything down so it was relevant to a CEO or a manager, or understanding the value of money in terms of time. And they also talked about professional development, things that they thought students needed to know in order to get a job. How do you get a job? How do you network? What is your virtual presence or brand? What should it be? How do you interview? What kinds of things should you do and should you not do? And also understanding and the ability to move up, that the first job is not your last job. And so how do you move up in an organization over time? And one of the things that the employers did was they recognized that there was a tremendous amount of information they were saying, or skills that they were saying that students needed to feel competent with. And the question they answered then was, well, what level of competency is needed? And they looked at it both from a PhD and from a master's. And so, for example, expertise and depth in their discipline, critical thinking, problem solving. PhDs should be an expert, master students should have mastery, or both should have mastery over communication. And so they went through these different skills to give some idea of how strongly they felt about those skills. And other examples are, for example, systems thinking. PhDs should be masters of it. MS students should be proficient in it. Or if you get to the economics part or the business skills, that was something that PhDs should be masters of. Master's students should be aware. And then the last one basically was awareness for both, and that was this machine learning, computer science, and so on. But I will say that what we've seen talking to employers since 2018, that even machine learning and computer science is something that they're expecting more and more proficiency and perhaps mastery of. So going back then to the academics, the heads and chairs and graduate program directors that came to the summit, they recognized that it was necessary to integrate these kinds of skills and competencies into their programs. As the employers said, they don't want us to lose what we're doing that's really good, but they want this in addition. And so one of the questions they ask is, what distinguishes a strong PhD researcher? And of course, it's a deep technical dive into a specific subject, the ability to discover, own, and solve problems independently, a high level creativity and innovation, and the ability to create new knowledge. And so the question is, how do you integrate these skills we've just talked about without losing the research emphasis and make these non-core research skills part of the program's culture? So the heads and chairs looked at, how do we make these opportunities available through their graduate experience? And so they had a number of ideas, such as, if you have a core curriculum for graduate students, you need to make sure that these different skills and competencies are in different courses. Or you can offer electives or special topic courses in some of these things, like science communication. They also recognized that if working with big databases was important, there were some schools that had those and other schools that didn't, and there were some fields that was easy to get databases and others not. So building some sort of open, easily usable set of databases for all students was thought to be an important thing. They also talked about how we can integrate these things into dissertations and theses, what one could do with the qualifying exams, and defining expectations and mentoring plans. But the one thing that really caught people's attention was the individual development plans. These individual development plans, or IDPs as they're called, is basically a customized roadmap for professional training and goals. They're used a lot in business, but they've been applied to academics, particularly for postdocs and also for PhD students in the last few years. Basically, the student does a skills assessment, what skills they already have, career aspirations, what career pathways are they interested in, what do they like to do, what are the skills that they need to get in order to reach their career aspirations, and then also professional development. What support is there that I can take advantage of? It's basically a self-assessment of both what they can do and also their career aspirations and professional goals. And one of the best places to send people is AAAS has Science Careers, My IDP, but many universities now have actually sometimes even require students to do this. And I put 3 different places up there: Purdue, Wisconsin, and Northwestern, but there are many, many more. And the idea is a student early in their career, maybe even before they start their graduate career, does this, and then they meet with their advisor and get advice on what skills or where they can do these things. And then over time, as they progress through their degree, that's revisited by both the student as well as the advisor, so that as the student's interests and skills evolve, they can be exposed to different kinds of activities. The other thing that really caught people's attention was Prenoti's career compasses, where she's taken, for example, a field like hydrology and looked at what a student as an undergrad, master's, or a PhD would need to do if they wanted to do this. And it starts off with, what kinds of research, and then what kind of courses, and it goes into what kind of co-curricular things you should do, and then into more in terms of networking. And So using these, the heads and chairs really looked at the different things that we already have in our graduate program and said, okay, how would these skills fit? So the first, as with Pernodi's things, was research. What ones of these skills could fit or be added to research? And some of it is quite obvious. I mean, the field of lab skills, the computational skills, big data, is something that easily fits into research. And many of them are like communication. Well, your thesis, dissertation, your publications, your proposer's conference presentation. But they also looked at, well, yes, but you should give presentations to other kinds of people. One, to your research group, but also maybe the department, undergraduate classes. Maybe you should be expected to write a press release. And so they went through and identified very specific skills, and then what kinds of things in a research environment you could have the students develop these skills. One example that the employers actually gave was in terms of organizational management skills, how to run a meeting. One of the things that the academics said was, well, we could have our students take turns rotating in terms of running a lab meeting or running a TA meeting. The AGU style talks or the elevator speeches is a way to teach them to give concise, organized communications to a group. Exposure to chain of command and business culture isn't quite as easy to do, but time management, have them use the time management quadrant where you have urgent on one and non-urgent on the as two columns, and then have the rows be important and non-important, and have students actually fill that in at different times during their career so that they could see where they fell and emphasize that it's the non-urgent important quadrant that you want to actually spend most of your time in. In terms of coursework, once again, they identified the different competencies and skills that one could learn through coursework. And a lot of it is things that are already done, but they also identified some other things that could be done as well. So for example, yes, when they're learning technical skills and disciplinary knowledge, make sure that you integrate systems thinking. In terms of communication, make sure that they get intentional instruction and significant feedback. Consider peer review of writing, which turns out to work much better, many people think, than faculty editing. Using large data sets in classes, actual having teamwork in classes and things of that nature. All those things were identified as possible ways of putting these skills and competencies into courses. Next, they went on to look at co-curricular experiences, departmental activities, clubs, outreach programs, internships, professional organizations, public engagement. They listed different kinds of skills that they thought students could develop in one of these co-curricular type activities, and listed some of the different kinds of things that students could do in these activities. Other co-curricular options, short courses, both given by professional societies, but also there's a lot of online ones as well. One credit courses, courses in other departments, certificate programs, presentations, a lot of different kinds of things they could see would really make a difference. So everything from career development or geoscience professionalism courses to just having alumni and returning interns give presentations. The idea of Toastmasters came up because then people would learn to speak and speak to different kinds of audiences. In terms of teacher training, it was mentioned NAJT has teacher training. Many universities have centers for teaching excellence. There's TA training courses. In terms of more business skills, it was pointed out that we have existing courses that could incorporate these. Economic geology, petroleum and mining geology, environmental geology, hydrogeology, or you could work with your business school to have a course or a certificate program. Also, in terms of really having true teamwork, where the team works together on all aspects of the problem, it was pointed out that there are many corporate challenges that are given, not just corporations, but also NASA and other government partners have challenges that students can participate in. And a good example would be, for example, AAPG's Imperial Barrel competition, where students have to work together on a problem. And then, of course, there's lots of workshops that are given, various websites that have information, diversity, equity, inclusion training, mentorship training, standards of practice, conflict management, and so on. Professional organizations like AGU, GSA, AAAS very definitely offer a lot of these. Some universities and departments have websites or have developed standards of practice or workplace guidelines in terms of how behavior should be, pedagogy, grant writing, knowing what careers are out there and what's needed for careers. CERC is a great resource, as well as AGI. And of course, the Earth Educators Rendezvous gives a lot of workshops and information on all of these different types of things. So what is the expectation of employers? Well, written and oral communication, capacity for learning and being adaptable, systems approach, programming, simulation, and data skills, and problem solving and critical thinking. I mean, that's the essence of what they really need when they get done. Employers will provide specialized job training as needed. There's both in-house training for some industries or government agencies, but there's also a lot of professional programs outside of a company that they may send you to. In terms of the workforce of the future, the next 10 years, they really were focused on the changes in terms of programming languages, the need for more data, centric skills in all fields, visualization, simulation. So basically those research skills that I talked about, them really thinking important in terms of data analytics, computer programming, and working with data in all ways, they felt was going to continue to grow and was going to be critically important in the future. So advice for students, they should be ready for dynamic job experiences. Jobs and careers are undergoing rapid change and growth. What is a job now won't necessarily be a job when the students get out. So when you start your PhD, you may be educating yourself so that you can do a job that doesn't even exist yet. That's why it's really important to be able to apply what you learn outside your field. And it's also important to be able to talk to and to work with people who are outside your field as well. Plus, you really need to show interest in the enterprise. You need to step out of your comfort zone. You need to demonstrate enthusiasm. It's really important to get something great done. It's not about having things perfect, but it's about getting something great done. So there was a lot of information on these slides and a lot of details. And the PowerPoint slides are available for you. And if you go to the link that's given here, you will come to the page that's shown. Not only are the PowerPoint slides here under AGU, AGI Heads and Chairs webinar, but there's a lot of other information as well. And there's also a link to a webpage for the Future of Undergraduate Geoscience Education initiative. And in both of those, any PowerPoint presentation that has been given is available. And also for both, there's archived webcasts. So for example, for the graduate one, all the panels, you can actually hear the panels. You can hear all the group presentations from breakout sessions and the discussions, and the same for the undergraduate. So if you want to hear David Moak talking about backwards design, you can go to the undergraduate geoscience education page, and you can actually hear him talk. You can hear David McConnell talk about different new pedagogies and things of that nature. So all that information is available and will be on the website, and we will continue to add additional information for the graduate efforts as we continue to work on this. Thank you.
Great. Thanks you so much, Sharon. It was a great presentation. Lots of great information. We've got a couple questions coming in here I was hoping you could answer. One going back to kind of the action plans from different institutions. Are those archived on this website, or is there a place that people can go to get ideas from other institutions as to how they can make changes at their own?
No, they're all individual, and we didn't ask people whether we could share them, so they won't be shared, but we will be taking them and putting out templates that show the kinds of things that different programs suggested that they would do. And we will be going back in, I guess, February and asking for an update. And when we get the updates, then we will also be adding in these are things that people did that were successful or that really worked. For the undergraduate effort, we had everybody do action plans when we had the heads and chairs. We had 109 heads and chairs come, and they all did action plans. And we asked for an update after 12 months and then 18 months and some of them 3 years later. And we're using those in the vision and change document as case studies, some of them without any attribution and some if the people are willing with attribution. And we'll try to do the same thing with the graduate ones as well.
Perfect. Now, you said you're going to be documenting the things that worked. Will you also be covering strategies that didn't pan out so well? So
yeah,
you can understand.
Definitely.
Okay.
Definitely. I mean, that you learn as much from what didn't work as did. And on the undergraduate effort, what we've discovered is it makes a big difference the size of the faculty and what kind of institution in terms of what works and what doesn't work. You have to do different things if you have a huge faculty than a small one. And if you're, just a 4-year or 2-year undergraduate institution versus, for example, let's say an R1, the kinds of things that you need to do vary in terms of getting people's buy-in and getting things actually done.
That's really good to know. I have a question here about support for faculty. So some of the things that you were talking about in terms of IDPs or, leading efficient meetings, are these things that are common for faculty to have experience going through, or are there resources for faculty to be able to mentor their students in this way?
There are definitely resources for faculty, both, for example, AAAS has them, the CERC site has them, and also if you go to the Earth Educators Rendezvous, there's often workshops that help with these things. Some of these things are things that faculty are used to, and some of them are things that faculty don't actually have those skills themselves and need to develop. And that's one thing I think that's critical to understand, is that the kinds of things that are being discussed as things that are necessary are things that are extremely important for faculty as well. And so getting a place where these resources are basically compiled is something that is important to do.
Absolutely.
And we will certainly consider doing.
Great. I think that'll be very helpful too. And then we've got 2 more questions I just wanted to throw your way here. One is about within the limited courses possible, especially for masters, is structured research a good way to get these skills as an overarching way, or are there good, I think you talked about this, good templates that can be adopted by different programs? So I guess incorporating these concepts into a structured research program being able to pull templates from other programs? Is that something that's available? I think you said that there are resources, and you gave a whole bunch of.
Right. And basically these slides, which are available, point to, for research courses and co-curricular things, what kinds of skills you can really build into your program for each of those different sort of areas. But I think for a master's only, you're going to have to do both. You're going to have some of it be in research, and you're going to have some of it be in actual courses that they take, as well as giving them the opportunities, or at least letting them know what these co-curricular opportunities are.
Great. And then our last one was about, can you talk a little bit about what's being done in other countries that is similar to what you're doing at Jackson School in terms of looking at preparedness for the future workforce at the undergraduate and graduate level?
I know that there has, for example, I think it's the UK that's done some assessments and really is developing the idea of students having badges where they have they get show competency in a skill, and they get a badge for that. In the US, people, particularly at the undergraduate level, have talked about e-portfolios, where places that students can electronically show, I have developed this skill and this is what I've done to show that. Canada definitely has evaluated what kinds of skills and competencies are needed for different kinds of employment. And I know I've gotten, been contacted from people everywhere from Australia to Nigeria asking about using what we've come up with and adapting it for their programs as well. So it's something I think is of interest everywhere globally in terms of what do students really need, particularly as things are changing so rapidly in the workforce.
Absolutely. Well, that's all the questions we have for today. So thank you very much for answering all the questions from the audience.
Okay, well, thank you very much,